In 4.9, we're going to be looking at quadratic inequalities. Now, the first question here is going to be fairly straightforward. As long as you remember inequalities from chapter 2, and as long as you remember graphing parabolas from earlier in this section, earlier in this chapter, we're just combining those together. It's fairly straightforward if you understood those. So let's just start by graphing the first inequality. So y is less than or equal to negative x squared plus 4. So let's start by trying to get the axis of symmetry. Now, it might help to think of this as y is less than negative x squared plus 0x plus 4. That tells you that b is 0. So if we want to find the axis of symmetry, we're going to do negative b over 2a, which is going to be b is 0, so that's 0 over, well, it doesn't matter what it's over, that's just going to be 0. So the line of symmetry then for this one is x equals 0. It's the y-axis. So then if we want to find the vertex, we just take that x value of 0 and plug it in. So we get y is equal to then negative 0 squared plus 4. Well, that's just 0 plus 4, which is 0, so that's the coordinate point 0, 4. Now, when I'm graphing the parabolas here, I'm just going to use 3 points. I've told you that I want you to graph parabolas using 5 points. Vertex, y-intercept and its reflection, and then some other point and its reflection. To save time in this video, I'm just going to do 3 points and then call it done. So let's plug in maybe 2 then to find another point. So y is equal to then negative 2 squared plus 4. So that's negative 4 plus 4, which is 0. So I plugged in 2 for x and I got 0 for y. That's going to be right here. And then I could reflect that point over here. Now, to draw the graph itself, we're going to have to first look at whether the line should be solid or dotted. So this is y is less than or equal to. So that tells us we're going to have a solid line. And so we're going to draw a solid line through here. Now it says we want y values less than this graph. So less than for y values would be underneath. So we're going to shade in the area underneath. All right, so then let's graph the other one. So that's for that one. Then over here we could do the axis of symmetry is going to be negative 2, or the opposite of negative 2, over 2 times a. So that's 2 over 2, which is 1. So the x-coordinate of the vertex here is 1. Let's plug that in then to find the y-coordinate. So 1 squared minus 2 times 1 minus 3 is 1 minus 2 minus 3. And that's going to be, let's see, what, negative 4? So the vertex here then, we plugged in 1 and we got negative 4 for y. So that is right here. And then we'll plug in some other point. Let's, I don't know, how about 0? I guess we can get the y-intercept. So if we plug in 0, we'd get 0 squared minus 2 times 0 minus 3, so that would just be minus 3. So that's about right there, and then we could reflect that and get that point right there. We'll call that good enough. And then we want to use a dotted line. It says y is strictly greater than, so we're going to use a dotted line for this. And then it says y is greater than, so that's going to be y values above. So we want to shade above the graph here. And then the solution is the area that is shaded by both. So that's going to be this area in here. So this darkly shaded area, this is the solution to this system of inequalities. So every point in that will make both of these inequalities true. Let's jump to something slightly different. Let's jump to one variable inequalities. Now, we're actually going to do something a bit weird here. So we have one variable inequalities, which means this really is a one-dimensional inequality. It should just be on a number line. But we're going to use the graph. We're going to pretend that this is not a one-variable inequality. We're going to pretend it's like y is greater than or less than or whatever, because it'll help us see where the inequalities should go. All right, so what we're going to do first is let's get 0 on one side of this inequality. So let's subtract 3 from both sides. And then we get x squared plus 2x minus 3 is greater than 0. And the reason we're going to do this is because now we can kind of pretend that this is like this, except we've plugged in 0 for y. So we can kind of pretend that it's like that. Now again, we were not given a y in here in the original thing, but if we get 0 on one side of the equation, then we can kind of pretend that we have a quadratic and we're solving for the x-intercepts. So let's do just that. So if this is a quadratic and we're trying to solve for the x-intercepts, we could say use the quadratic formula to find the values of x that will make this inequality, at this side of the inequality, 0. Now again, we're trying to find where this is greater than 0. But if we can find where it is 0, then we can go just to the sides of those points, and that will be where it's greater than 0. Okay, so let's use, say, the quadratic formula. Or if you wanted to complete the square, you're absolutely welcome to do that. I'm going to use the quadratic formula. So this would be negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So that's negative 2 plus or minus the square root, then 4, let's see, so this is negative 4 times 1 times negative 3, that's going to be positive 12, all over 2. So that's negative 2 plus or minus the square root of 16 over 2, which is negative 2 plus or minus 4 over 2. And I guess I should be saying x equals for all of these. So then we get one of the x values is x is equal to, let's see, negative 2 plus 4 over 2, which is 2 over 2, which is 1. And the other one then would be x equals negative 2 minus 4 over 2, which is negative 6 over 2, which is negative 3. So again, if we're thinking of this as a quadratic, as y is less than or y is greater than instead of what it is, we would have an x-intercept at 1, and we would have an x-intercept at negative 3. Now I'm not going to worry about graphing the rest of it. So what we're caring about here is when is it that this is greater than 0? So think about if it were this again. So when is it that x squared plus 2x minus 3 is greater than 0? Well, if we think about this being a parabola, think about which way it's going to open. So this has a positive leading coefficient, which means it's going to open up. So I'm not going to worry about accuracy here. It'll look something like that. And so what you can see here then is the parabola is greater than 0 right here, and it's greater than 0 right here. And this part right here, though, this is where it's less than 0. So that means that anything to the right of 1 is going to be positive, and anything to the left of negative 3 is going to be positive. So then the inequality should say that any x value greater than 1 and any x value, let's see, what, less than negative 3? Those will make this true. And you could test that just to be sure. So if you want to say plug in negative 4, you would see that you'd get a true statement here. If you were to plug in 2, that would be greater than 1, you would get a true statement here. If you were to plug in, say, 0, well, actually, we can go ahead and do that. So 0 squared plus 2 times 0 would be negative 3. So that's saying that negative 3 is greater than 0. Well, that's not true. And that's because this part is negative, so it makes the inequality false. Actually, you know what? Let's go ahead and plug in 2. So if we were to plug in 2, this should make the inequality true, because you can see this part of the graph is greater than 0. So we get 2 squared plus 2 times 2 minus 3 is greater than 0. Well, that's 4 plus 4 minus 3 is greater than 0. That's 8 minus 3 is 5 is greater than 0. That is true. 5 is greater than 0. So anything to the right here is, any x values to the right here are going to make this inequality true. Any x values to the left here are going to make the inequality true. The only place where this inequality is going to be false is where this x squared plus 2x minus 3 is less than 0, which is down here. At the bottom of the page then, the last piece, what would the solutions be if the original inequality had been a less than or equal to rather than a greater than symbol? Well, then it would be flipped the other way. Well, first of all, we would have, in our inequalities, we would have greater than or less than or equal to, and then greater than or equal to, because this is less than or equal to. But it would be flipped the other way around. So when we subtract 3 from both sides here, we would get x squared plus 2x minus 3 is less than 0. So then we would be looking for the places where this is less than 0. So then we would be looking for this part where the y values are less than 0. So that's going to be between negative 3 and 1. So we would get x values that are greater than or equal to negative 3, and x values that are less than or equal to 1. Now we could, if we wanted to, write this all in one inequality. So that would be a perfectly acceptable answer. Or if you wanted to write it instead as negative 3 is less than or equal to x, which is less than or equal to 1, that would be perfectly acceptable too. This just kind of combines both of the inequalities into one. Either way of writing that would be just fine.